Hello everybody, in this video we're going to talk about how to describe some end behavior of polynomial functions, and specifically what we mean is the graph of the polynomial function, okay? So what is end behavior of a graph? Well, it's how the graph behaves, or the behavior of the graph as x approaches positive infinity or negative infinity. So we're going to say as our graph moves to the left, what is happening to our graph in terms of, is it going higher, right? Is f of x also approaching positive infinity? Or is it going lower? Is f of x or y, is it approaching negative infinity? And we're going to do that as the graph goes to the left, that would be negative infinity, and as the graph goes to the right, that would be our positive infinity. So for polynomial functions, the end behavior is determined by two things. Number one, it's determined by the function's degree, so that's going to be our exponent. Our degree is either going to be an odd number or an even number. And also the sign of its leading coefficient. So is our leading coefficient a positive number or is it a negative number? So we have four different diagrams that we can look at here, right? Because we have two options for degree, odd or even, and we have two options for our leading coefficient, positive or negative. So that gives us four options of how our graph could behave. So let's start up here in the top left. We'll call this number one. So let's say our degree is odd, right? So that means our exponent is an odd number, right? 3, 5, 7, 9, something like that. Our leading coefficient is positive. So we have our first number that we have listed there is a positive number, no negative sign. Notice what our graph is going to look like. It's going to have this general shape right here, right? Now, depending on what our numbers are, we could be stretched or shrunk, but it's going to have that general shape. The end behavior is what we're focusing on, not necessarily the part that's in the middle. So the end behavior we see down here, right? For this one, we're going to say as x approaches negative infinity. So as we move to the left, our graph is going to be going down, right? Or approaching negative infinity as well. And on the right side of this graph, as our graph approaches positive infinity to the right, our graph is going higher, so it is also approaching positive infinity. Okay. Now, sticking with degree being odd, but now our leading coefficient is negative. So essentially our graph is reflected here. So now our graph, we're going to say as we go to the left, as we approach negative infinity, our graph now is reaching higher, so it's approaching positive infinity. And then on the other end, we would say as our graph moves to the right, as we approach positive infinity, our graph is going down, so it's approaching negative infinity. Okay, so those are our two options for when our degree is odd. So let's now move down here and let's say, okay, now if we have an even degree, so now our exponent is 2, 4, 6, 8, something like that. And now let's say we have a positive leading coefficient. So now we're going to look at our end behavior here. So we see our general shape here. It kind of looks like a W, if you will. But now we're looking, okay, as our graph moves to the left, we are getting higher. So as x approaches negative infinity, y is approaching positive infinity. And then on the right side of our graph, we're going to say as x is approaching positive infinity, our graph once again is reaching higher, so it's also approaching positive infinity. And our last example that we could see here, we'll call this number 4. We still have an even degree, but now our coefficient, our leading coefficient, is a negative number. So once again, it's essentially flipping or reflecting our graph. So now it's kind of more like an M shape. But once again, we're talking about our end behavior. So as our graph approaches, as x approaches negative infinity to the left, our graph is going down. So y is approaching, or f of x is approaching negative infinity. On the right side of our graph, as we approach positive infinity to the right, as our graph moves to the right, our graph is moving down, so approaching negative infinity. So we're going to look at one example for each of these different types right here below. So we're going to describe the end behavior of each graph. So the first one that we see, we have a negative leading coefficient and an odd degree. So the first thing I'm going to do is just kind of sketch this graph. Okay, so there's my x and y axis, and we have a negative leading coefficient and we have an odd degree. So my graph is going to look something like this, right? So now I know I'm looking at the end behavior. So let's say we're going to say f of x approaches, that's what that arrow means. And we're going to say this is positive infinity as x approaches negative infinity. Okay, so my infinity symbols sometimes are a little bit suspect, right? So we got to make those a little bit better. So anyway, as our graph moves to the left, we're getting higher. So now let's talk about the right. So we'll say f of x is approaching, not equals, f of x approaches negative infinity as x approaches positive infinity, right? So as we are moving to the right, our graph is going down. So that would be our end behavior for number 1. All right, for number 2, we'll draw our graph again here. Notice how now we have a positive leading coefficient and we have an even degree. So this is going to be our graph that kind of looks like a W, right? So it's going to look like this, right? Something like that, okay? So now we're going to focus on our end behavior here. So let's say f of x is approaching positive infinity, right? As x approaches negative infinity. So as we move to the left, our graph is going higher, okay? On the right side, as we move to the right, f of x is still approaching positive infinity, but now x is also approaching positive infinity, right? We're getting larger and larger with our x values, okay? All right, next example. Now our leading coefficient is negative, and we have an even degree. So very similar to number 2, but now our graph is going to look more like an M instead of a W, right? We kind of reflected that over. So now we're going to say f of x approaches negative infinity on both sides of this graph, but now we're going to say this is as x also approaches negative infinity. So as we move to the left on our graph, the graph is going down. Now on the right side, we're going to say f of x is, once again, we're going to be also approaching negative infinity because we're going down. Remember, f of x is like our y values, that's up and down on the graph. And this is as x approaches positive infinity, right? Because we're moving to the right on our graph, okay? All right, so our last example, we have an even leading coefficient, positive leading coefficient, and an odd degree, okay? So we have an odd degree there. So now we're going to draw our graph. So now it's going to look similar to what we did on number 1, but kind of a reflected graph from number 1, right? So maybe something a little bit more like this, okay? So now we're going to talk about our end behavior. So f of x is approaching negative infinity as x also approaches negative infinity, right? So as we move to the left, our graph is going down. And on the right side, we're going to say f of x approaches positive infinity as x approaches positive infinity, right? So as we move to the right, our graph is going up. So in this video, we talked about those 4 major types of polynomial graphs, right? The 2 most important pieces of information from your function are the leading coefficient, the sign of it, is it positive, is it negative, and also the type of degree you have, right? So is your degree odd or is it even? So that's going to give you 4 different options for your end behavior there. So take a look at those, memorize those, and you'll be good to go for any polynomial function.